welcome to the stage our own advisory board member, Hamish McKenzie.
Thanks, Lucien. Good morning, good afternoon, or even good evening to some of you, depending on where you are in the world. My name is Hamish McKenzie, and thank you for joining us for today's session, which is AI-driven process optimization, achieving faster turnarounds and higher margins, sponsored today by Retrocausal. First off, it'd be great if you could just tell us in the chat who you are, where you are, just so we get a feel for who's joining us. It's always nice to do that. And while you do that, get settled in, grab a coffee, water, or whatever. Couple of bits of housekeeping first. The session is going to last an hour, as most of you will already know. I'll be introducing the topic, I'll be introducing our guest speakers, and we'll be getting a lot of valuable insights from them, obviously, but we will try and leave time at the end for some questions from you, the most important people in the room, the audience, of course. So please put your questions in the Q&A function in the platform here, not in the chat. It just makes it a lot easier for us to find them. It's more likely that you'll get your question answered, and it just makes my life easier, which I'm always very grateful for. So please use the Q&A function for all your questions. Don't wait till the end. As soon as something pops into your head, get it in the Q&A function there, and we'll try and get to it at the end. If we don't get to your question for whatever reason, we will do our best to get it answered post-session. All right, as I'm sure you're aware, most of you at least, we do lots of these events every year, and there are 2 more to go after this one. This year we have the Cybersecurity Day, ICS Cybersecurity Day on October 17th, and Manufacturing and Supply Chain Day on December 7th. So check out the IIoT World website to find all the details on those. Now, however, it's time to focus on this session. And as I said, we're focusing on process optimization, achieving faster turnarounds and higher margins using AI. So we're going to look at how AI-driven optimization enhances efficiency by streamlining workflows, reducing production times, ultimately leading to faster turnarounds. We'll discover how AI helps maximize profit margins through improved resource management and cost reduction. We'll be looking at some successful real-world case studies showcasing some significant improvements in those areas, and I know our audience is always like those real-world case studies. And we'll be examining how to overcome data barriers to access the right quality and quantity of data, and understand why so many proof of concepts fail in that area, and how to transition successfully from proof of concept to production. And we'll also be defining some best practices for integrating AI into manufacturing processes for optimal results, and discussing some strategies for scaling industrial AI cost effectively across multiple manufacturing sites. So we've got an awful lot to get through. Fortunately, we have some real experts with us today. So I'd like to introduce them to you now. First up, we have Zishan Zia, who is CEO and co-founder of our sponsor today, Retrocausal. He has a PhD in computer vision, and he is on a mission to transform manufacturing with AI co-pilots. He used to be a scientific leader at Microsoft's HoloLens division, where he invented AI technologies to assist frontline workers across multiple industries. And prior to that, he shipped IoT platforms and visual defect detection software for manufacturers at Siemens and MVT Tech GmbH. He's authored more than 20 peer-reviewed publications, which have been cited by every major lab from MIT to Stanford, CMU, Apple, Google, Baidu. Anybody who's anybody has been quoting Zishan's stuff. And he's also credited as an inventor on almost 20 US patents or patent applications. And he's shipped numerous AI-first products, including the Microsoft HoloLens that we just mentioned, Vuforia AR platform, and many others. So thank you for joining us today, Zishan. Great to have you here. Next up, we have Eve Salti, Senior Director at Microsoft. She's a 20-year tech and business leader, currently the Senior Director at Microsoft's Azure AI Engineering organization, responsible for scaling and commercializing their AI solutions. She used to be head of strategic platforms at Google Cloud, and before that, she had multiple roles across business development, sales, marketing, leadership, Microsoft, startups across US, across Europe, leading 200-person teams and $600 million businesses. So she definitely knows what she's talking about. She's a native of Greece. She holds a master's degree in several technology and business certifications from the London Business School and the University of Washington. And she also serves on the board of WE Global Studios, which is a full-stack startup innovation studio supporting female entrepreneurs. And so she's obviously extremely busy lady, and we're very lucky to have her joining us today. Thank you for coming, Eve. Next, we have Jiva Prakash, who's COO at Saint-Gobain. I know he has been having some connectivity issues, but we're hoping he's going to be able to join us one way or the other, either via the video or phone. Shiva has a strong software engineering, technology, R&D, industrial automation, and digital manufacturing background. 25 years of leadership experience with engineering research and development groups, digital manufacturing global capability centers at Schneider Electric, Bosch, GE, ISRO, various global and APAC roles. So he also has a wealth of experience. And he's currently part of the Global Chief Digital and Information Officer leadership team at Saint-Gobain. There he is building and leading a talented team to develop and implement data, AI, and Gen AI architecture strategies. So thanks for joining us, Shiva. Hopefully you will be able to join us. And last but by no means least, we have Michael Kuhner-Schlinkert, who is co-founder and CEO of Cthulhu. He's an expert in Industry 4.0 and machine learning. He founded Cthulhu in 2018 to make AI more usable in this kind of an industrial manufacturing setting that we're talking about. And he's the visionary behind technologies like AutoFL, which is Automated Federated Machine Learning. And with his company, he's developing the Federated AI platform, which is a software solution for industrial AI, enabling large-scale cross-factory collaboration in industrial applications without data exchange to scale AI cost-efficiently across manufacturing sites. So we're also very excited to have you with us today, Michael, as well. Thank you. And finally, a very few words about me, definitely the least important person in the room. I am a former IDC analyst. I've been running my consultancy and advisory practice here in Munich, Germany since 2006. And I work with CEOs, founders, and other senior executives in Europe, North America, in all sorts of technology areas, including IIoT, but others as well, helping them improve their growth efficiency, essentially, across their businesses. And that does include also integrating generative AI into some of their operational processes, especially things like marketing, sales, that kind of thing. If you'd like to know more about what I do, then please look me up on LinkedIn. I'm pretty sure I'm the only Hamish Mackenzie in Munich, so it shouldn't be too difficult to find me. With all of that said, one final reminder, please do get your questions into the Q&A function, not the chat. Just makes it a lot easier and you're much more likely to get your question answered. So we will look forward to seeing what you come up with. And so with all of that done, let's get into it. And before I start chatting to our guests, Paul, could you bring up the first poll question? We just want to get a quick idea of where our audience is at in terms of where they are, where you are on your optimization journey. So if you can just take a couple of minutes to answer that for us, that would be incredibly helpful. And while you're doing that, I'm going to start having a chat with our guests, as I said. And I wanted to come to you first, Zishan. There seems to be, well, obviously doesn't seem to be, there is an awful lot of hype surrounding generative AI in particular, but AI generally as well, in manufacturing and also everywhere else. So I just wanted to get your perspective on, is that hype justified? And what do you see as the main applications for Gen AI and AI in the industrial sectors in particular?
Absolutely. Thank you, Hamish, for the wonderful introduction. I think the hype is absolutely justified. There's so much that's happening in manufacturing and beyond, thanks to machine learning. It's both predictive machine learning and generative machine learning, generative AI. I think people have heard a lot about what predictive AI is doing and has been doing, from visual part defect detection to predictive maintenance to helping workers avoid assembly mistakes. But what I find even more interesting is what generative AI is helping achieve and enable in manufacturing. Where my heart is at is in process and improvement. So helping industrial engineers improve processes. If you look at the US Bureau of Labor Statistics, they say that industrial engineering is the largest shortfall field in the US right now. So it's really the toughest to hire sector is manufacturing engineering and industrial engineering. It's harder to find manufacturing engineers than software engineers or data scientists or any other field. But manufacturers still need to run factories. And what generative AI is enabling us or enabling manufacturers do is optimize assembly processes. For instance, the AI can tell you to move a bin closer to the operator, so that's going to save them several seconds, or it's telling you how to lay out a cell so that it can minimize walk time. And then obviously there are applications like being able to program robots automatically, generate robot programs automatically. And then everybody's been talking about ChatGPT, of course. There are tons of applications there, just general business applications that apply to manufacturing as well, from writing material, documenting things faster, and so on and so forth. But I think the hype is totally justified. If anything, I think AI is underhyped rather than overhyped.
Wow, very bold statement there. But I'm sure that I know you're right in terms of the excitement around it, in terms of the benefits that the proper application of this within an industrial environment can bring in all sorts of areas, from safety to sustainability, as well as efficiency and margins and all the rest of it. And I'm sure we'll cover some of those later on. All right, so thank you for that, Zishan. I want to try and get maybe now a snapshot of where we're at. So I wanted to come to Eve next and ask you, Eve, what does the overall AI ecosystem, the AI model ecosystem look like right now for someone who's maybe, and I think there are a lot of people like this in the audience, someone who's evaluating the different options, different services available. Where are we at from your perspective? Eve, I can't hear you. Can anybody else? Does anybody?
Oh, I'm sorry about that. Yes. Well, thank you so much for the questions, Hamish. That's a very, very interesting question that a lot of people are asking, because I think the good thing and the bad thing is that there is a lot of choice when it comes to AI capabilities. So just kind of like at a bird's eye view, what we see is like, and what also our audience needs to know is that there is a lot of variety, and depending on the use case and the scenario that they have, they will need to pick the right model or the right service for what they're trying to achieve. The traditional AI services, I think Zishan kind of touched on that, around computer vision, face recognition, right? There is also a lot of services around speech to text, text to speech, translation, speaker recognition, a lot of them associated with contact center or customer service. Then you have services around language understanding, text analytics, translation again. And that was before the Gen AI era. Now we have generative AI, which is basically large language models that have been trained on a large corpus of information that can do a lot of different tasks at the same time. So depending on whether you have a use case that requires one particular model that can do the work, this will be a very effective way to go about it. You don't need to employ a generative AI or a frontier type of AI model. But if you want to do 2 or 3 things at the same time, like you want to transcribe a call, and then you want to extract sentiment, and you want to summarize or write an email, a personalized email, then probably generative AI and a large language model like GPT-4, ChatGPT, DALL-E on images, Whisper on transcription and translation might be a better option, because then you can do kind of like, a couple of different things at the same time. But also now what we see coming up is also small language models is emerging as a new category of AI capabilities that can also be very nimble, fast, and can drive the right ROI for the team that is using it. And last but not least, we see also a lot of multimodal capabilities. So, the ability to really insert not only text in a prompt, but also image, a video, and audio. So now it enables you to do a lot of different things and to have a much richer experience on the other end.
Yeah, absolutely. As someone who, as I mentioned at the beginning, I also work with my clients to involve things like this in particularly in sales and marketing, and the speed at which these things are evolving, and the things you can do, which like even a couple of months ago you couldn't do, or the quality of the output is just increasing very, very rapidly. All right, so thank you for that, Eve. I'm going to now check whether we have Shiva with us or not on the line. Do we have him? Can you hear us, Shiva? Or is he not? I guess we haven't been able to get him on yet. We'll see whether that situation changes. All right. So what I'm going to do now, then, I think we've set the scene, and I think what I would like to do next is really talk about some of the real world impacts that AI can have in terms of driving efficiency, but also other benefits like safety, sustainability, which I mentioned a little bit earlier. So Eva, if we just stay with you for a second, what do you think are some of the most common business scenarios and use cases where we see AI driving efficiencies in particular?
Yeah, that's a great question because, again, what we see a lot of customers really gravitating towards kind of like the largest pain point that they have. And I think that's a very smart way to go about it. I don't think people should adopt AI for the sake of adopting AI, but they should start with a business need first. So we see a lot of organizations struggling to increase product productivity. So, we can use AI, for example, to drive developer efficiency because there are a lot of large language models that can create code, they can create documentation. So, it can really make your developers much more effective. We also see a business need around automating business processes, right? So all of organizations have a lot of documents, whether it's structured or unstructured, contracts, agreements, invoices, what have you. And it's a very cumbersome kind of like task to go through them, extract the right information, and do whatever other further processing needs to happen. So document process intelligence, I think it's one that we see across the board, across all industries, types of companies. Basically, how you can do document classification, how you can improve claims processing, how you can drive a report summarization. These are things that usually take a lot of human resources, and if there is a way that we can leverage an AI model to automate this, whether it's to extract the relevant information, apply kind of like a vector database or an AI search capability so that you can find things more easily, then, the teams can see the ROI on the other side. Also, another area that we see is around improving customer experiences. We've all been on the other end of a customer care call, whether it was a good or a bad experience. So we can use AI models to help the agent be much more efficient, right? So that they can have more information when they interact with the customer. We can also help them through summarizing the conversation, transcribing the conversation, also translating if you're in a global type of setting. And you can help the agent, or you can help the customer directly do some kind of like knowledge mining so that they can find information faster, easier, and they can provide a better customer service at the end of the day. And last but not least, we see kind of like another set of use cases around creative content, whether it's marketing teams, advertising teams, programs like GPT-4, GPT-4o. They can generate a lot of great content. Again, we truly believe that the human should be in the loop. I don't think the content should be 100% automated, and nothing of this, none of these use cases should be 100% automated, right? I mean, what we're saying here is like use an AI capability to support your teams, and you should always have a human in the loop to make sure that the results are appropriate, especially if you need to fine-tune things. But creative content, product ideation, product development, a lot of AI models like DALL-E and other vision models can really help with that. So these are a couple of the top use cases that we see across the board.
Yeah, and I mean, I think a lot of the conversations I'm having anyway are to do with helping people improve, enhancing people in their roles, accelerating their work rather than replacing them. And I'm going to use the same joke that I used in the first session that I did today, which is that when they invented the car, they didn't go out and shoot all the horses. So it's not about replacing people. Yes, there are some roles which will probably get replaced, or some jobs which will just not become relevant anymore. But in most cases, what it's about is learning how to, for people learning how to utilize these tools to enable them to do, either to enable them to do what they're already doing better or faster, or to enable them to do new things that perhaps they weren't able to do before, but now with the help of AI, they can. So I think it's very important to point that out. All right.
Maybe Hamish, to add to that a little bit the manufacturing perspective. I think that's also kind of a huge
absolutely
topic we want to address. Thanks for bringing up the whole focus picture of the Gen AI. What I actually missed there are actually kind of the use cases that we basically addressing directly in the shop floor. Where instantly predictive maintenance is it's common, it's quite known. But more from the rule-based perspective, and what we kind of can do is, since a couple of years, even much better, is basically really predicting actual potential failure with an AI-based model to really anticipate potential failure. And this is becoming actually also since the recent economic worldwide downturn a little bit much more efficient, important, because what we're seeing is that customers are doing a shift from basically CAPEX to OPEX, so that they kind of really looking more to go to as a service models, also when it comes to machines or even parts. We having a lot of customers who are discussing basically a topic of pay per part. If you want to kind of enable such equipment as a service models, it's super critical that you really know how your machine will behave and also how your customer will basically use them. And these are things that you can predict very nicely with deep learning models. Besides that, what we're seeing there as well is predictive quality control. That's also a huge topic. And manufacturing. Zishan, our computer vision expert, probably knows that really well from that kind of in this case, you can basically detect defects much earlier and even predicting them at the beginning of the process when you did the first steps, how the quality will be at the end of the process. And this is super important because we'll say these kind of solutions, they save resources, they save cost, and this is in the end what counts when it comes to manufacturing. And a relatively new topic is what we're seeing is basically value chain optimization. So you basically where you really look cross company and really try to think, okay, how I can basically optimize my process, not isolated in my own organization. How can I basically think further and really optimize it across multiple organizations? A little bit tricky, I think we'll come to that later again, because it's basically heavily related to the willingness or not willingness to share data. But this is a trend that we're seeing, which will probably accelerate in the next years, that we will basically see really integrated supply chains or manufacturing processes that basically not just limited to one single organization.
Yeah, absolutely, and I think so. If you take both sides, if you're looking at this from product development right through then to maintenance, then you can see that the benefits really do spread right across the entire value chain, and so that's incredibly helpful. Thank you, Michael. I wanted to now. So you already mentioned a little bit about this, I guess, but I think Zishan has some particular examples in terms of robotics, because robotics gets a lot of attention in these discussions. So how are the improvements affecting things in that context, in the robotics context within manufacturing, Zishan?
Yeah, I really appreciated the discussion on the importance of humans, actually. Robotics
it's actually forgotten about sometimes.
Absolutely. Certainly a very underappreciated aspect of manufacturing and in other verticals as well, how much humans really do. If you go to these factories, you'll everybody talks about robotics, and it seems like at a modern factory floor, everything would be done by robots. But then you go to what are really golden standard factories, and 80%, 85% of work is being done by humans, actually. But to your question, 50 years ago, of course, robotics and IoT started making an impact on manufacturing, and they've had a huge impact, massive impact indeed. But like I said, it's still today you go to a fancy factory, and you'll see maybe, especially on the discrete manufacturing side of things, you'll see that 15 to 20%, outside of 15 to 25% of tasks, everything else, 70 to 80% is still done by humans. And the reason is that those 15 to 20% of tasks are the only ones that can be replaced by off-the-shelf robots. So welding, painting, pick and place, those kinds of tasks. For everything else, yes, you can build a highly custom automation system, but that takes millions of dollars, right? You have to fabricate some mechatronic component, and then you couple things together, and you build in some kind of automation. I'm actually a little bit bearish on how machine learning is impacting robotics, despite the billions of dollars being poured into it. If you actually look at the science behind it, in the deep learning toolbox, there is something called behavior cloning that could potentially be used to help robots become more effective. But in fact, it's not been very practical and very useful. In fact, I was just reading this paper by Google DeepMind, just came out a couple of days ago. I was just reading it yesterday. It's called Aloha Unleashed, and it talks. They recorded 26,000 demonstrations of a particular task over 8 months by 35 teleoperators. So 26,000 tasks, 26,000 examples, and they were only able to hit 75% success rate with the task-specific model. So, for a lot of Gen AI kind of applications, if you're trying to generate an email or an ad copy, that's fine. You can have a human in the loop, improve things, and so on. But robotics is not really working out. If you're in a manufacturing setting and your robot works at 75% accuracy with that much training data, you're in trouble actually. Mm-hmm. So I'm actually, again, for the traditional use cases of robotics, I'm very fantastic. I think that's where the majority of robotic investments should go into. But when it comes to AI, I think we are still in need of a couple of paradigm shifts. And unfortunately, dollars can't really time or accelerate necessarily paradigm shifts. Oftentimes when, venture capital dollars go into these kinds of research problems, hard research problems, they are focused on, immediate ground impact. And that that just doesn't happen. You need to take your time, explore a lot of alternative approaches until you get to the right kind of solutions. And I think we are a little bit away from those. And in the meanwhile, humans are going to stay important. I think, the next 10, 15 years, when it comes to frontline work, humans are not going anywhere. If anything, to Eve's point, a lot of Gen AI's, impact is more on the white collar kind of work rather than on blue collar work. So, for what it's worth.
All right, so yeah, you've injected a note of skepticism there, or at least introduced some of the challenges, and I want to focus on that now a little bit as well. So you've already mentioned a little bit of stuff there, Zeeshan, and I'm going to come to all of you, and to also you, Eve, as well, even though it wasn't necessarily planned. But I'm sure there are blockers in terms of what you're working with as well. But Zeeshan, so can you give us any other examples of where this has not been particularly effective, and what are the problems, what are the blockers, and how can you address them? How can they be removed, those blockers?
Yeah, again, the same kind of thing when I go in and I talk to plant managers or directors of operation, they tell us that there's a lot of investment from the VP and the SVP levels at manufacturing firms and in warehousing firms and a couple of others in deploying robots. Whereas when they actually get those robots, they're not as adaptable. you do invest $1.5 million to replace that one worker at that one station, and then it turns out that you need to rebalance the line because you need to increase the volume. And now what do? Or you need to add another product variant to the mix, and then you have to bypass that robot altogether. But I think a key shortcoming has correspondingly been, how do you apply AI? And for instance, Michael talked about predictive maintenance. Great, to the extent that machines are doing these jobs, you have IoT to monitor, to understand, to track what machines are doing, to help predict challenges there. But how do you help human operators become more effective, right? If human operators are going to continue doing 75% of assembly jobs for the next decade, while at the same time younger humans just don't want to work in a factory environment, you'll have to deal with temporary workers who are doing these jobs, and these temporary workers are not very well trained. Then how do you help temporary workers become more effective? So that's something that I used to do when I was at Microsoft, building HoloLens and those kinds of tools, to make frontline workers more effective, give them just-in-time training, provide them with guidance and so on. And I think that's the kind of, you don't need these relatively big, bulky devices to guide operators. I think what we really need is AI that can provide more, that can fix this blind spot in manufacturing and other domains that is around human work. Because what is a human doing? What's the cycle time? Where are they making mistakes? How can they be improved, right? Can we provide just-in-time training? It's a morning shift is about to start at 6 a.m. and 4 of your operators are on holiday today. They're calling in sick. What do you do? If you don't run the line for an hour, you're losing hundreds of thousands of dollars, right? How do you enable an operator to just come on that station and start becoming productive in 5 minutes, right? I think those are the kinds of AI applications and tools that we really need to be focusing on. How can you understand human work? How can you track human work? How can you provide just-in-time training? How can you do root cause analysis on top of human work, as opposed to just thinking of IoT as something that connects to machines? Because the fact of the matter is, the ground reality is that machines are still doing a relatively smaller portion of work when it comes to even a very modern factory.
Okay, yeah, interesting perspective, and I'm always a big fan of bringing people into these discussions, because sometimes the people aspect gets ignored. But obviously, in addition to the people, then another key topic around all of this is data, and a major blocker is limited data access, or especially when it involves getting your hands on data from different places. So, Michael, I wanted to come to you and ask you, how can manufacturers overcome some of these data barriers, making sure that the right quantity and quality of data is accessible, and also that obviously you can then extract insight and value from that data as well?
Yeah, sure. I think first of all, it's important that to keep in mind that the data that we think of when we speak of all these large language models, this is public data, and this is basically 10% of the data that we have available worldwide. The majority of the data, the more than the 90% of the data, that lies in the factories, and this is the actual treasure, and that's a treasure that we can't access usually. Maybe first, before we speak how we can overcome the barriers, maybe let's clarify what the barriers are, and because you can actually categorize in quite nicely, which makes it more easier to understand why it's so difficult to get access to data. And I like to differentiate there between legal reasons, strategic reasons, and technical reasons. The legal reasons, I think it's quite obvious to most of us. We have GDPR here in Europe. There are other similar laws which make it difficult to use PII data. Then we also have HIPAA, or the export control also, for instance, makes it difficult in some cases to use data, by the way. A lot of people don't know is that production data, if it can be basically used to reconstruct a dual use good, falls under export control. You're not allowed to send it out of the country. So a lot of kind of potential pitfalls which you need to keep in mind. But the most common one, and that's the one we usually deal with, are strategic reasons. A strategic reason basically is when you would like to have data from someone else, when you have a use case which involves multiple data owners. Let's say your customers, you have many opinions, so it's not that trivial to get them all under one umbrella and find a common way to share data. That's usually a really tricky part, and a reason for that is that a lot of them would like to protect their data for sure. I mean, there are some data can contain trade secrets, can contain IP, so there are good reasons to protect it. And another common reason, which depends a little bit on your use case, are technical ones for sure. Modern smart factory generates more than 2,000 terabytes per month. So it's definitely questionable if you would like to send all this data into the cloud, right? So you can, and I'm pretty sure Microsoft Azure will be capable of that. But I think you should think twice what you would like to send to the cloud. And this brings a little bit to the point, how can we do this? How can we really navigate through these barriers? There are a lot of initiatives which have been created in the last years. What we've seen here, for instance, in Europe, like Gaia X, Manufacturing X, the Data Institute. So a lot of initiatives which has basically the idea to create a foundation so that you basically have standards, also legal standards, which allows you to share data. What we see there is that people are really interested in that, and companies would like to join them. But in the end, it's more kind of the mentality, what do I get out of it? It's the really interesting data is not shared there. And this is a problem. And I mean, it's also on the other hand, understandable that you would like to think twice if you would like to share your data there and really share it openly with potential competitors or so. There are better ways to do that. And that's also what I'm evangelizing for is that we really rethink how we deal with data. I mean, data is usually distributed. It's distributed across multiple data sources, distributed across the world, across multiple data owners. And what we usually tend to do, and that's what we did a lot in the early years of IoT, is we collect the data and send everything to the cloud and build a gigantic data lake. The thing is, we can also do it the other way around. Instead of sending everything to cloud, where we train our AI model, we can also go the other way around and send our AI model from the cloud to the data and keep it there. And keeping the data with its data owner, that's basically kind of the approach that we see as a really promising one, and what especially bigger players start to adopt. When you really keep the sensitive data private, when you keep the trade secrets in your own organization and do not share them, so that in the end, what you do is you train locally a model and you share only in the end the learnings or the parameters or the weights, so on. And then in the end, you combine what you've learned in the cloud to a new model and share back an improved model. You can combine this with anonymization, for instance. And the nice thing about this kind of way is you can basically learn from other organizations without learning about them. And this is a really powerful way to do that. Who paid attention in the intro in the beginning, we are a federated learning company, so that's and the technology behind it is federated learning. So that's the reason also why I first am really convinced that this is the way to go, and this is the way to solve our data problem, because it's really able to really solve the legal, strategic, and technology reasons. So if you need to think how you can basically bridge data barriers, and you kind of not limited to just one single database. If you really need to think bigger, then this is definitely the technology to go to.
And are those issues also key in terms of the fact that a lot of companies who do try to implement these projects, or at least proof of concepts, for example, that they don't work, and if so, or whatever the reasons are. Perhaps you can talk a little bit about that, and how is it possible to stop those POCs from failing and to get to a successful production environment?
Yeah, absolutely. Yeah, data access is definitely one of the key problems, especially access to the right data. I mean, we don't want to have access to all data. We need specific data which reflects especially our process, which reflects the rare errors that happens, which also labels how we the pseudo failures and all these. So we would like to have good data sets. We like to speak there of curated data. So we need the data that reflects the actual behavior, not just, I don't know, the big factory which has been set up, which has all those sensors, and the other one's the interesting one who has less sensors is less reflected in the data set. That's not what we want. We really want to reflect the real world there, and to get access to this, that's super critical. And this is also part of why many POCs fail, because they look a little bit too narrow. So I mean, when you capture data in the lab, you have just a really small piece of the puzzle. But when you want to move forward, the reality looks completely different. And what we see there is, besides that access to the right data is one of the key aspects such solutions fail, is that when you do not consider the fact that you will basically leave the lab at some point, that you really need to think a little bit broader, that you need to think, okay, how does this apply to the actual process there? You will not be able to transfer it to a process that is slightly different. You will not be able to transfer it to a different machine generation. And this generates a lot of cost. Means cost of scaling is a huge reason why many POCs they make a step forward, and maybe they make it to the MVP, and then at some point they are shut down because you cannot really achieve a positive ROI. And this is a really important part what a lot of companies missed in the last years, that they did AI for the sake of doing AI. But in the end, you want to do it because you would like to save money or you would like to generate revenue. So you need to really pay attention from the beginning that you will be able to achieve a positive ROI. And the way how you can do that is that you really consider this in the design of your POC from the steps. I mean, it's absolutely okay that POCs fail. I mean, that's the idea of a POC, that you try something. But what's super important is that you try something, but then that you also prove the value. And that you really push things forward, so that you really also consider different variations, so that you take into account, okay, I can design for a really specific use case a model. This only works for this specific configuration. Is this fine? Will this be okay? Will this be also the reality that we will have on our shop floor? Or do I need to think different and need to design a model that generalizes better, where I can also, for instance, deal with different materials, and that I can also adjust to a shop floor which has maybe different manufacturing execution systems. I mean, the thing is, every factory is different, and we need to deal with this heterogeneity. And if we design a solution that only works in one place, we will have expensive integration projects, and then the fun really starts, and the bill goes through the roof. So,
I would briefly add to that, as
go ahead.
Typically, if you are a champion within a large firm that's trying to bring in new technology into your firm, what you really need to do is understand your internal buying process as soon as possible. What I've often seen is, you are a middle manager, you understand the problems that are on the ground, you bring something in and you're piloting it, but your leadership, you don't understand your upper management's goals, you don't align expectations of timelines and delivery, and most importantly, you don't understand the buying process as soon as possible. Oftentimes, the people, the champions bringing in new technology into factories, into warehouses, what have you, are relatively young. And this is the first time they're trying out some new piece of technology. And so far, they just don't understand the buying process within their own organization. So oftentimes technically the POC will pass, right?
Yeah.
It's able to deliver the right kind of goals and objectives. Although that's sometimes you see that challenge as well, that the ROI or the expected value is not decided upon in upfront. But oftentimes, even when you deliver all of that, a vendor will come in, they deliver all of that. You just don't know as a champion what your internal buying process is. When is the next budget, right? When can you put CapEx versus OpEx related constraints, all those kinds of things. That's what I would really recommend to internal champions. On the other hand, if you're a vendor, what's worked for us wonderfully is don't do POCs, or do POCs as a part of a larger deployment contract. Say,
Right.
okay, we're gonna do a deployment contract. First 2 months are gonna be free. You can back out if you don't see your ROI. That way you avoid going through a POC process and then restarting the negotiations for a potential deployment. I think that's what really kills a lot of AI and technology deployments. What I'm seeing is it's not often technology's fault itself. It's the challenge is often with the buying process itself, and people, either vendors or the inside champions, not really understanding it.
Yeah, right. Yeah, that's also the reason why we do not do POCs. Where if a customer asks us, hey, can you do a POC? Then we say, hey, you can talk to another customer. You can see it running there in a factory at large scale, on a global scale. You can go almost to every Siemens factory nowadays, and then they can basically check it out. What we want to do for our customers is we want to, I don't really like this word, but we want to do a proof of value. It's really consultant speak, but that in the end, when you basically introduce the software, and it can be for every kind of software, that afterwards the customer really knows what kind of value do I get out of it if I buy it, and if it really makes sense, and if it in the end also will result, as we've mentioned before, in a positive ROI.
Yeah, absolutely. All right, so we're starting to get a bit tight on time, so I need to move things along now.
Sure.
I want to, Paul, can you bring up our second poll question, please? Because we've heard what you guys think about the blockers, but I want to see what the audience thinks about their biggest barriers as well. And so while the audience gives us their opinion on that, I wanted to come back to Eve, and I want to generally turn things around to a more positive perspective now, and say, okay, what can we do? What can we do to make these projects work better? How can people get started? So Eve, you're more than welcome to also talk about a couple of barriers if you want to, but I would also like you to talk about, from your perspective in your world, what are the best practices and recommendations for businesses on how to get started on all of this?
Absolutely. And I do agree with my co-presenters here on the barriers. This is exactly what we see from our end, people getting stuck in POCs and not really showcasing kind of like the ROI, and then struggling to sell it within the organization. So I would say, if I can summarize a couple of best practices, is, and some of them are just like, very common sense. I would say start with a clear business goal. I think it's already mentioned here, like a lot of people are adopting AI because it's cool, because it's fresh, because it's new, because their CEO is telling them to do it, because the board is telling them to do it. I would say, like, start with the pain. Where is the biggest pain that you have? Where is it, where your operations are not really streamlined, they're not optimized, they're not automated? Start with the biggest inefficiency, and then see if you can, really apply an AI capability there to automate a task, to improve a customer service thing, to gain some insights, to anything that you can quantify. You can set up specific KPIs, specific success indicators, and track them over a small period of time. Then you can see if this works, and then you can sell it within the organization, and you can move forward. The second piece, I think it was mentioned by Michael very eloquently, the value of data. Because in most cases, even if you use a traditional AI model, or if you use a generative AI model, a large language model, whatever it is, most cases you will need to fine tune it. It means like, you will need to customize it with the most up-to-date information, whether it's through a RAG pattern, or infuse it with your own specific information through prompt engineering or whatever. So you need to be able to have access to clean and relevant and well-labeled data. And, kind of like the whole notion of data governance and how to handle it, how to manage PII, privacy, compliance, all of that. So this is kind of like a big bulk of, tasks that you need specialized teams to drive. Also, what I see working in organizations is when they introduce a center of excellence for AI, because certain departments will be early adopters compared to others. So how do you really establish some best practices within the organization, and how do you share what worked and what didn't work across other departments so that you don't have to repeat the same mistakes? Another thing also is to make sure that you don't forget about responsible AI. It's it's very, I would say it's not very common, but you should be aware in the bias you might be introducing by using an AI model versus another. So how do you really build or monitor bias in AI models? How do you drive transparency and traceability so that you understand how the model is processing this information and the decisions that they're making? And then, of course, I think, this was brought up as a barrier. Investing in training, in retraining, reskilling, we all have to do it, right? I'm on the engineering side, and we ship things. We used to ship things every 3 years. Then it was every year. Now it's every week. So I and my team, will need to reskill and retrain almost every week. And that's kind of like the pace of innovation that we see across the board, right? So not only how you hire for the right individuals that can really learn these new tools, these new processes, but how do you retrain and reskill existing employees to be able to kind of like, bring this experimentation and this culture of change within the organization?
Yeah, no, absolutely. And one of the things that can help with that, I attended an interesting event a few months ago, and she's the chief marketing officer of Monday.com, and she said, when you're and nothing to do with manufacturing, but in terms of that change process, she said that they made huge strides as soon as they stopped calling it change and started calling it improvement. So if you think about having an improvement program rather than a change program, then it's a lot less scary for people, and everybody can get behind the idea of improvement, or they should be able to. Otherwise, why are they in the job? But change is scary to a lot of people, and especially when in the context of things like AI. All right, I do want to try and fit in one or two questions. So, Michael, I know you wanted to talk a little bit about scaling. So you got 1 minute to try and give us some insight into how manufacturers can scale better, and especially in terms of achieving faster turnarounds and higher margins.
Yeah, absolutely. Happy to share some principles how we can basically scale more cost efficiently. Eve already touched on some of these. Try to bring that a little bit more technical perspective. So I think it's known to many that data preparation is a huge part of every data science project. It makes up to 80% of the project, and that's also a huge cost driver. And this is super important to keep this in mind from the beginning of the process. So read the data selection. This affects how you in the end also can set up your model. And if you have the right tools, especially when you're also in a distributed setup, you can reduce this heavily. So there are good ways to basically get rid of this 80% when you especially standardize such processes across departments within your organization, or if that's the case, across organizations, if that makes sense. What we really suggest there is to think of seeing this as a continuous part, so that it's not a part that you do once and then you're done. What we're doing at Katool is we always ship the data preparation pipeline together with a model. With a simple reason is that like this, you can iterate super fast, and you can also fail fast. And this is what you want. You might need to go back to the start when you would like to change something in model. So this is something what you need to keep in mind when you basically would like to stay cost efficiently, that you find ways to do this also in an efficient manner. Another topic also touched on is basically generalization. So ideally, work towards one model. Ideally, you find a way that you have a really good generalizing architecture that in the end for your different variations of your process with different machine generations, with different materials, you can address this as one model for all variances, for all locations. This is a huge cost saver. This is incredible to see what kind of numbers some customers are coming up with, who basically were able to do that with our support, that they really kind of were kind of going from a really big model zoo down to one model to basically everything around, for instance, PCB printing. So, and you can print different PCBs, but in the end, it's always the same. And these are kind of the parts that you need to find out when you also design your model, that you basically look, okay, what are kind of the nuances that I really haven't come in across my process that I can really go down to these really generalizing models, because this is a huge cost saver. And if you do all this, then data scientists are precious resources. So ideally, if you do a good job, you can really also work there with less resources, with less data scientists. It's not that I would like to get them unemployed, but it's so hard to get them. So it's important to optimize your process that you can also work with less. And that's in the end also cost saver, and also to use their tools like AutoML, for instance, or AutoFL, if you would like to really kind of help also your data scientists to accelerate the work. That's definitely good. So yeah, there are tools out there, and it's definitely important to use these. There's just a few. If data also stays locally, then you also save on cloud costs. I think all these will add up to much better ARI and added value.
Okay, thank you for that, Michael. We are unfortunately now out of time, but we will, if you ask a question which we didn't get to, then we will try and make sure that we get back to you on those questions. I know you wanted to talk a little bit about compliance, Michael, and a couple of people were asking about the regulatory side of things. So maybe we can get back to them after the end of this session. But in the meantime,
topic, then they also happy to reach out. We got the luck that we basically consulted the EU Parliament actually on the AI Act regarding industrial AI. So we have a little bit knowledge on that. So if that's kind of a topic, it also drives us in all our projects.
Yeah, it's unavoidable.
Yeah, it's absolutely.
Yeah. All right. Brilliant. So thank you, first of all, to our panelists for all your great insights. Thank you especially to Zishan and Retrocausal, the sponsor. Without your involvement, all of you and our sponsors, then we wouldn't be able to put together these great events and give the audience so much value. So thank you very, very, very much. Thank you also to our attendees for joining the session. Hope you found it useful. We will get back to you with any unanswered questions, as I said. And with that, it's time for the next session, which is Transforming Manufacturing, the Role of Data and IIoT in Achieving Sustainability, sponsored by HiByte. And all that's left for me to say is thank you again, and I hope you enjoy the rest of the event, and have a great day. Thank you.
Thank you.